Understanding Indian Railways Signalling Systems Design. Here is a comprehensive educational article on the Indian Railways Signalling Systems Design, divided into 30 clear paragraphs. Introduction. Indian Railways is one of the largest railway networks in the world, carrying millions of passengers and freight every day. The safety of these journeys depends heavily on the efficient signaling systems in place. In this article, we will explore the design of Indian Railways signaling systems. History of signaling systems. The first signaling system was introduced in India during the British colonial era in 1853. Since then, the system has undergone several transformations and upgrades to meet the growing demands of the railway network. Types of signaling systems. There are three types of signaling systems used in Indian Railways: block system, automatic train protection (ATP), and interlocking system. Block system. The block system is a traditional method of signaling where each section of track is divided into blocks. A signalman at the beginning of each block will raise or lower the signals to indicate whether the next block is clear or occupied. Automatic train protection (ATP). ATP is an advanced system that detects the speed of trains and automatically stops them if they exceed a predetermined limit. ATP systems are used on high-speed sections of track. Interlocking system. The interlocking system ensures that signals can only be cleared for one train at a time, preventing collisions between trains. Signal head design. Signal heads in Indian Railways signaling system consist of two parts: the semaphore arm and the fixed part. The semaphore arm is raised or lowered to indicate whether the track is clear or occupied. Semaphore arms. Semaphore arms are typically made of metal and come in different colors, shapes, and sizes depending on their function. Red signals are used for warning against a specific danger, while green signals indicate clearance. Fixed parts. The fixed part of the signal head consists of a frame that supports the semaphore arm and displays additional information such as the direction of the train or any special instructions. Signal aspect designations. Indian Railways signaling system uses different color codes to convey different meanings. Asterisk red, warning against specific danger. Asterisk green, clearance for passage. Asterisk yellow, precautionary signals, indicating caution. Red signals. Red signals are used in situations where a train may be endangered by another train or an obstruction on the track. Green signals. Green signals indicate that the next block is clear and that the train can proceed with caution. Yellow signals. Yellow signals warn drivers of potential hazards ahead, such as speed restrictions or impending obstacles. Track circuits. Track circuits are used to detect trains on a particular section of track. They consist of two parts: a transmitter, a section of rail, and a receiver, another section of rail. Pantograph signals. Some sections of the Indian Railways network use pantograph signals, which display signal information in real time. Signal posts. Signal posts are used to display signal heads and carry additional information such as train schedules or special instructions. Switching signals. Switching signals are used to control access to branches or sidings. Level crossing signaling. Specialized signaling systems are used at level crossings, where the road and rail networks intersect. Distant signals. Distant signals indicate whether a section of track is clear or occupied. They are typically installed before a station or junction. Home signals. Home signals display the clearance status for trains entering a station or junction. Starting signals. Starting signals allow drivers to start moving from a stationary position. Stops and stations signaling. Signaling systems at stops and stations ensure safe passage of passengers. Junction signaling. Specialized signaling systems are used at junctions, where multiple lines intersect. Automatic train operation. Auto. The auto system is being implemented on some sections of the Indian Railways network to reduce human error and increase efficiency. Automatic warning system. AWS. The AWS system is integrated with ATP and provides additional safety features such as automatic speed restriction, train protection and warning system. TPWS. The TPWS system prevents trains from exceeding predetermined speeds and warns drivers of potential hazards. Electrification of signaling systems. Many sections of the Indian Railways network have been electrified, reducing the need for manual signaling systems. Advancements in signaling technology. New technologies such as optical fiber communication, OFC, and automatic train regulation, ATR, are being implemented to improve efficiency and safety. Thanks for watching.